Hello everybody and welcome to the channel Llamawe Official. Here we do DevOps. And for the long program, we are currently trying to develop a Kubernetes cluster based on Ansible, with Wireguard, with Core DNS, with a lot of things. And for tonight, the goal is to debug and create a correct CNSpec bundle to test our Wireguard implementation. CNSpec is a new tool. It's the successor of InSpec. And with that, you can do compliance tests on infrastructure. So let's take a look. So basically, what you have here is the first report of our CNSpec bundle. And it shows that everything is broken. And that's good. That's good because that way we can find why it's broken and debug it. And once it's completely debugged, normally this check runs for every test we do and can tell us right away if we broke something again or not. And so that way it does compliance tests. So as it is broken now, I'm currently writing a small helper here to dig into the virtual machines to debug everything. So inventory here, and let's go with that. We have a small helper here. We'll see if this helper helps, if this helper works. So I put a sleep for 3,600 seconds, so an hour, to avoid the virtual machine to be crashed before. So normally midstream, we will have to redeploy everything. And let's see what it does. Host key verification failed. Yeah, that I know. How did I handle that with Ansible? To do that, I had to put Ansible host key checking false. So we will put that in front here. Let's hope it works. Yeah. So it doesn't work, but it works. It doesn't work in the way that what I added there passes the blockers of the host key, but we have another blocker just right after. Permission denied, public key, password. Okay. The weird thing is that it actually deployed just before. So that's weird that it doesn't work anymore. So, why? Let's do a ping. What's the syntax for the ping already? the syntax for the ping. Let's see. No, not the built-in module, just a ping from the inventory. It's a module as well, yes, of course. So in that case, if it's a module, let's call it here. Okay, permission denied. Publier password. Ah, I know why. I know why. That's because I'm not root. Yeah, it works better when you are root. Yes, because in Vagrant by default, you access the Vagrant box with the user Vagrant. And in our case, we deploy our stuff with root because we use the shell provisioner inside the Vagrant box. So there is no security concern, it's just a Vagrant box. And what's important is not how, from where Ansible access, but how it deploys. There we have it. So let's see if you have a Wireguard process. It doesn't seem so. So first thing first, I would like to check. The name of the service is systemd networkd. Because Wireguard is integrated into that. Yeah, of course. So systemd networkd works. It's there. So first thing we'll do. I mean, it's a silly check because if it doesn't work, we can't even access the VM. But just for the sake of completion, we will put it here. Okay. Now, what can we do to assess that Wireguard works? We could, for instance, but I try to think how to replicate that in the CNSpec profile bundle. Yes, we have the network interfaces to check. Let's do an if config. Do we have the command installed? Not found. I don't want to install network command if I don't need them. Is there... let's see how to check network interfaces. IP address. I think, of course, it exists already. Yeah. So we have ETH0, ETH1, but we don't have any WireGuard thing. There we have a problem. Because we don't have any WireGuard interface. This one is my network here because I use a bridge. This one is the one set by Vagrant for provisioning. Wait, let me just check. Yes, that's Ansible host. So that's actually not the one. Yeah, that's the one for Ansible to access the virtual machines. But the one missing is the one started with 10.95. This one doesn't exist. So that means that WireGuard doesn't work yet. Do we have some log? We certainly have some log. But do we have some log that we could relate to WireGuard? Normally you should have the log of the system the network D. So it's a journal CTL something. Journal CTL. I never remember the commands for journal CTL. Journal. Journal CTL système D network D. Let's do a raw journal CTL first. Journal with an L up. Okay. There is absolutely nothing related to WireGuard. And we finish here our deployment, but still there is nothing associated to WireGuard. It is as if it wasn't taken into account at all. That's weird. Setup WireGuard device, setup WireGuard network, systemd network restart. The handler systemd network restart is called. Do we have the files? Normally we should have the files. And what is their content? We have the files with the public key. Maybe it's the public key the problem, but I mean, I would like to have somewhere a log that explains the problem. Do we have the network itself? The configuration? Yes. The net dev match the network. So let's check. Install Wireguard. Okay. Quick start. Is it a fixed name? WG0? Ah, there is a Wireguard show Wireguard command. Oh, interesting. Let's see. Let's see. Nothing. Okay. Nothing. Incredible. But the command exists. That's just, there is nothing to display. Let's reboot the service. We never know. Why don't have I any return? Status. Ah, there we have some log. Wireguard key provided by public key has invalid length. Okay, ignoring assignment. Unknown key name in section Wireguard peer ignoring. Well, in your missing private key or private key file, dropping network device WG. Okay, so I understand. Now I have my problems. Okay. So let's look at this file then. That's not this one, that's this one. So, on wireguard.net dev, private key for Wireguard, it's there. But that's not the correct length. Okay. You have the public key here for each of the peer. For each peer. So it's only a problem of key length then. Okay. So in that case, we should go to the mock. Generate pre-shared key. No, it's a peer. So, OpenSSL P key. Ah, do we need the base 64 for this one? I don't think so. That's maybe the problem. I mean, I saw two different things, and maybe the base 64 is not needed. So, in order not to destroy our first attempt, we will go towards that by repeating the code, commenting the first one. Okay. Okay. So that would be the key. Okay, and that's the pub. So the public key. Okay. Then we get rid of that. And we can destroy an environment and start again. So just, what did I do? Just to remember the last line. Okay, just the previous one. Yeah, that's a system status. Yeah, that's a simple system status. Okay. I will write this line in my helper. there. Okay, and we can go back on it right after. Okay. Let's destroy this environment. I mean, it was also nearly sure that the problem was there, because that's the only part that differs greatly in my setup compared to the documentation, compared to the way others do. And why I want that to be different, that's because I consider that's the bad pattern to have cross exchanges in the mesh directly of the secrets. And I consider that the provisioner should handle the secrets distribution in the whole mesh, and each node of the mesh should not have to do that. And that's why I want to use ECSL, OpenSSL or TLS, because I want an agnostic provisioner, so I don't want to first install tools on the provisioner to do stuff, just for a specific piece of software. No, that's the wrong one. Okay. Sorry. So the machine didn't shut down properly. It happens sometimes. Okay. Back on track. Let's do a quick final destroy to be sure. So to ensure that we will destroy... no, I already do that when redeploy, so it's not needed. But I will destroy my inventory. I will destroy the SSH key. Let's go. Let's redeploy everything. Wireguard, Ubuntu. Hop! C'est parti. Let's go. We have for 5 minutes, something like that, of deployment. Oh. What? Ah. Okay, so my script is wrong. Yeah, that's due to the fact that here the public key is generated from the private key, but I didn't change the name here. Okay. So let's redeploy. Let's clean and let's redeploy. Okay. Okay, the keys are correctly generated. So now we just do an upgrade, which normally should not be too long, because I created the virtual machine just before starting the stream. So it should not be too long, I hope. And the lock on it is 1 hour, I think. So every hour the lock is burning to provide a new update. Let me just check that. Yeah, cache 60 minutes. to make everything far more quicker. So I commented the score threshold here, because actually when I will put it, if the test fails, it stops the script. That's good when you are in a CI/CD environment, for instance, because it breaks the CI environment, which is supposed to be the case when a test fails. But in our current situation, I want the system to continue existing because I want to debug it. So that's why it's just commented temporarily. Okay, upgrade done for the first node. Then we start the second node. You see it's very quick once the upgrade is done. That's by far the longest step. I should implement Pomodoro in the stream as well, and during the breaks of the Pomodoro method, I should redeploy every time. That way I can do something else, look at my plants, for instance, and meanwhile it deploys. It takes some time. I hope the Ubuntu apt repositories are up and not completely breaking as usual. Because it takes some time. That's the annoying part when you play with a classic system. Maybe in the future we will deploy also our stuff directly on Flatcar Linux. And this kind of problems, we won't have them anymore. Because that's the principle of Flatcar Linux, to be immutable. So the version stays and the updates are done by block, so the whole system in a row, to ensure correct testability. But with this kind of system, we have to be sure of where the data are, how the logs are treated, because when it switches, it destroys everything that is not stored in a correct container. By container, I mean data container. So sorry for this time. Takes some time, actually. I hope the Ubuntu repos are up. Otherwise, the stream will quickly end. If I can't install Wireguard, how can I test it? Shit. Oh, sorry, I shouldn't say that on Twitch. It takes a lot of time. I'm a bit afraid. But the process is stuck. But what? There's a problem with the machine. No. Upgrades, unattended upgrades. So meanwhile, while it tries to install something, we can try to debug yeah, our stuff. So failed to decode Wireguard key provided by public key. Invalid argument. So the problem of length disappeared. But we have an invalid argument on line 12, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, even 12. Wait. What? Ah. Of course. Let's have a Wireguard config example. The public key and the private key are actually in base 64. According to that. Wireguard config example. No, oh. ClickOps. I want a file, not your shitty interfaces. I just want to see how the key look. Yeah, it's base 64 something. So why did I have to remove the base 64 stuff? Wireguard key generation. So I want the code git. I want the code for Wireguard Linux. Oh no! I want the code on GitHub, please. Oh, it's. Oh. This interface is not ergonomic at all. GitHub Wireguard. I want something readable. Yeah. Mirror only. Don't care. Gen key. The gen key command. Okay. Command gen key. What? What? No. Gen key content. Okay, it's dev urandom. But that's the length that interests me. Yeah, it's still stuck. So, no care. So actually this one is useless. And why it has settled for this one? Generate public. From key, generate a public key. Okay. But the private one is simply a random stuff? That sounds weird. Okay. So why do they include the curve 25519 if they don't use it? Ah, okay. So the public key is related to the private key, but the private key is just random. Okay, there was a confusion. What? So let's do some tests. What's the difference between that and that? Yeah, that doesn't exist. Okay. Gen key. Because Wireguard is not installed by default. Yeah. Yeah, I have to do pre-shared key afterward. Yeah, that's what I do. Open SSL gen p key algorithm the correct one and out the correct one. And out. So normally it should work. But then what happens? Does it truncate it? Okay, so that's weird because the last error, it was the correct way of generating the keys actually. So I don't understand why it didn't work. Let's start again. So we want to destroy everything. Yep. 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 Let's see if it destroyed correctly. No, it doesn't. Let's destroy that. Let's destroy that as well. Okay. And then let's rebuild the artifact. And let's redeploy. It's a simple Diffie-Hellman curve. Where lies the problem? In the end, I will have maybe to install Wireguard on the provisioner just to generate the keys. It's stupid, completely stupid, but... Let me think. I really don't like when a tool wants to reinvent cryptography. Because cryptography, is a touchy point. You have to really know what you do. So I don't like that idea that at the end I will be forced to use the Wireguard tool to generate crypto elements. Are the Ubuntu repos down? That's possible. Yeah. So if it doesn't work, then I will have to install Wireguard in the mock, and that means that later when I want to deploy that correctly, I have to handle a Wireguard problem, a Wireguard binary in the Vault environment. Great. Just to generate keys. So OpenTLS, OpenSSL, OpenSSH, and Wireguard. 3 different libraries just to generate crypto stuff. What could go wrong? What could go wrong? So let's look at it. Okay. 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 So what we basically do is install apt get install Wireguard push. Actually, I will install that not here, but in the provisioner background file here. Up. Then I should put a warning somewhere saying that you need in the mock warning, you need the Wireguard CLI to generate the keys. Up. Wireguard gen key. Up. Which basically creates the base 64 already, if I understand the thing correctly. Okay. And then afterwards, we'll take the pub key. Here. Here. Okay. Okay. So that means that check Wireguard is running. System D is running, yes. That's a silly check, but that means that works. But that's a silly check because that's not the problem there. No, check will be to check, or check will be to check that the interface is up. That's the correct change. And of course, as I destroyed the thing manually, I have to clean my stuff. Okay, that's done. Then, first thing first, I will create the boxes. It will take some time, but then you should have a Wireguard installed. It's Wireguard utils we need. Wireguard tools or Wireguard utils, I don't remember. But it will tell us. So I have to think my architecture again. Yeah, I think the vault will have satellites for every cryptographic tool needed. That's the way I will handle that. Satellites around the vault. One with Wireguard, one with GPG, one with SSH, and one with TLS, of course. And these satellites will distribute to the vault the required secrets when asked. So we rebuild the box. I will take some water. But at least we could check that the CNSPEC bundle works. So once we redeploy, we can write the tests to check if the network interface is up. And then maybe afterwards check if everything goes through it between the nodes. And if it's encrypted. Then we will have our Wireguard tested. Next step, core DNS. It compresses a big box. That makes me think that I should buy some disks. I start to be a bit low in disk space. It's slowly creating the box. No worries there. It takes a bit of time because it's nearly 2 gigabytes. 2 gigabytes, sorry. So, yeah, it's normal. And in terms of disk space, I still have some. Yeah. It's a quiet stream. Yeah. It happens sometimes. That's the way we develop. I mean, when these kind of things happen, generally you have other computers to do stuff with. So I do something else. As I'm currently streaming, I try to keep the focus on what I'm streaming to you. So yeah. Maybe one day I should do a video about my setup because it's a bit peculiar. A lot of screens, 4 computers meshed together. Yeah. And also smartphones. Computers and smartphones meshed together. Listen, if it continues that way, maybe we will have to stop the stream because it's... Oh, it was slow. I just had to say it. The computer is afraid of me. So, the provisioner, it's done. Now we have to do the base box and then we'll redeploy again. In the case of the base box, it's just upgrading. Sorry. Okay. Okay. Upgrade done. Now we create the box. We compress. Normally it should take less time than the provisioner box. Oh, I forgot that. There. Yeah, captivating moments. It's a chill stream, I warned you. There's still 20 minutes to go. I hope it will be finished soon. That way we can redeploy and see if the keys generated by Wireguard CLI work. And then we should have our network device up. Then we write our test to check that the network device is up. And normally we have a pretty good Ansible rule to deploy Wireguard. A chill stream. Ooh. But normally the network interfaces should be up, and for the next stream, then we should be able to start core DNS. We'll see. And after core DNS, so currently you see bind 9, but it will be replaced by core DNS. And after core DNS, we have the etcd cluster to do. So core DNS, etcd will be deployed in Podman. And once we have that, we have our satellites for our kube cluster, and then we can go back on our kube cluster. First step will be to ensure that the Kubernetes CSA approver works. That's why we develop our WireGuard mesh and our core DNS stuff, because that way we can, inside core DNS, map correctly the host names, actually the FQDN of every node with their IP, courtesy of WireGuard, and which is a check requirement for Kubernetes CSA approver to work correctly. Then once we debug the Kubernetes CSA approver, we should have our kube with a better security. Then we will improve iteratively the security of this kube. And once that's done, and we have our etcd external cluster and stuff, once that's done, we will do the observability part. Then everything related to stateful set and then we will start to put some workload on that. Stateful sets, basically that's the backups and the upgrade path. Basically. And in stateful elements, I see Postgres, I see Redis. What else? etcd, but etcd it will also be done before with the Podman cluster. So Postgres, Redis, I suppose an Elastic somewhere. And currently, maybe MariaDB for Matomo, for instance. But maybe I will look at the competitor of Matomo, the new one. I don't remember its name. I hope in terms of features good. Because if we can start... Wireguard command not found. Oh. What? It should be there. It's possible that it doesn't use. It's possible that it doesn't use the correct box. So let's destroy everything. So once the stateful sets are done, the first workload we put is a GitLab cluster, actually, because with that we can iteratively improve, do the automatic updates with Renovate and so of our whole system, whole infrastructure, whole kube cluster. Basically, at the beginning it will be only one kube cluster. And once we have that stable, so the rhythm of iterations, then we will start create multiple cluster, but for that we will need a correct IAM. So that's another project. And once we have that, we can start to deploy multiple cluster and so. Let's try. First, we'll do that. Okay. Then we'll try to do that. I have the feeling that it's still an old one and it didn't import the new one because it's too quick. Yeah. So, due to the lack of progress, actually there was some progress, but I mean, yeah. So I will see if it cleans that correctly. Then I will check the volumes in the live environment. Okay, the volumes themselves then. Storage. Yep. Yeah, that's these ones. Yep, we have to re-import them. Okay. So what I'm proposing is that I will continue working on that, and but you saw the main idea is that we will improve our test here. So you saw that at the beginning it failed, and then when I put systemd networkd it worked. But I want to put some more tests here, like the Wireguard network interface to check if it's up. So that's the main concept here. This bundle file provides a way to do compliance tests and documentation at the same time, as you can see here. And as it runs continuously, like every other test in your CI/CD pipeline, it ensures that your infrastructure is constantly aligned with the policy. First of the policy is that it works. So that's a good one to test, that it works. But with that, you can also ensure naming conventions, security levels, and stuff like that. So it's very good for that. And so it replaces inspec. We'll start to deploy that and create this kind of policies on the whole project, step by step, slowly. But after that, we also include some other test suite like Checkov, kubesec, and so, to ensure that our kube cluster is secure enough. So, as for today, as for this stream, we will stop there. Let me center. Yeah, I'm centered. We will stop there. And next stream, Wednesday next week, if everything works correctly, we should start the core DNS deployment. We'll see. That's the life of a developer. It often fails. So, first I will stop the recording, then I will put the off-screen closing. Tschüss!